Okay, in section 3, what we're looking at is general rational functions. And when we talk about general rational functions, one of the things that we're talking about is that we've got one function that's made up by a fraction of two others. And one of the things that we're really interested in is to make sure that there are no common factors except for plus or minus 1. In other words, I don't have the function like something that would reduce, like say, x plus 1 times x minus 2 over x plus 1, x plus 2. And if you'll look on this one, these plus 1s cancel out. And that's a common factor. So for purposes that we're looking at today, this will not happen, okay? And when this is true, we've got three things that we can look for. One, that the x-intercepts of the graph of f are the real zeros. So in other words, this graph will cross the x-axis where the top is equal to 0. The graph of f is a vertical asymptote where at each zero of q of x. So on the bottom, we have a vertical asymptote when the bottom is equal to 0. We cross the x-axis when the top is equal to 0, okay? And the graph of f has at most one horizontal asymptote, which is determined by the degrees of m and n of p and q. So in other words, we look at this degree right here, and we look at this degree right here, and we will know what kind of horizontal asymptote we're going to have. So these things, the complexity now ratchets up a notch, so we just have to pay attention to what's going on. Some general rules on your horizontal asymptote. Okay, so what we're going to look for here is the degrees in the numerator and the denominator. And this first guy says that if the degree of the numerator is less than the degree of the denominator, in other words, if this number that is our degree on the top is less than this number that's the degree on the bottom, then we have the line y equals 0 as a horizontal asymptote, okay? If these two numbers are equal, if m and n are equal, then you have the line y equals a over b as your horizontal asymptote. And if m is greater than n, there is no horizontal asymptote, and the end behavior then becomes a slanted asymptote that has the shape of a over b, which is that leading fraction again, and then x to the m minus n, so whatever these guys would subtract to. And we'll look at all these different things. There is a pattern to all of this. Follow the pattern. As we go through these problems, you might work each one also on your own to make sure that you get it. And then you'll see how all this stuff kind of connects. All right, so let's look at a graph of a rational function. And one of the things that we're asked to do is state the domain and the range of this rational function. And they give it to us as y equals 6 over x squared plus 1. Well, think about now some of those rules that we were just looking at on the previous page, on our previous slide about horizontal asymptotes. And the first question that we want to ask is the degree of the top part of my equation less than the degree on the bottom? Well, on the top, even though we don't have an x, this would be as x to the 0 power on the top. Okay, this would be x to the 0 power on the top. And 0 is less than 2. So one of the things that we have to be aware of is that we're going to have a horizontal asymptote at y equals 0. Okay, that's one of the places where we're going to have a horizontal asymptote according to our rules. And so we can fill that guy in. Let me see if I can get a little bit of a darker color here. We can fill that guy in. We would just make a little dashed line right here where y equals 0. That's my horizontal asymptote. Okay? And that's the only asymptote that we're going to be able to discover right now. That's the only rule that can be met. You usually can meet just one of those rules at a time. And so then what we're going to do is we're just going to look at this guy by plugging in some different points. Okay? And so what we're going to do is just take that -3 and plug it in for x. And so what I'm going to end up with is 6 over negative 3 squared, and that's a negative 3 being squared, okay, which is going to be 6 over 9 plus 1, which is 6 over 10, okay? And so, if you want to put that as a fraction so that we could, or as a decimal so that we could graph it a little bit easier, it looks like this. And then, when we work the next guy, we're looking at 6 over negative 1 squared plus 1, which is going to be 6 over 1 plus 1, which is 6 over 2, which is 3. And then we'll work the next guy, which is going to be 6 over 0 squared plus 1, which is going to be 6. And then the next guy, 6 over 1 squared plus 1, which is going to be 6 over 2, which is 3. And then the last guy, which is going to be 6 over 3 squared plus 1, which is going to be 6 over 10, or 0.6. So here's how our points are going to shape up. So if I draw this line, I come out here to negative 3 and 0.6. I go to negative 1, 3. I go to 0, 6. I go to 1, 3. And then I go to 3 and 0.6. And I just picked these points at random. There's no specific reason why I chose them. But here's your graph. And it's going to look something like this. It will never cross the x-axis because on the top of the function, there's nowhere that 6 is going to ever be equal to 0. So there's your first graph of a rational function. And you can use your calculator. Definitely use your calculator to back that up and to see exactly what your graph is looking at. And while you're graphing it, you can look at a table of points. And I'll get a video ready for that as well and link it in here so that you can see that. Alright, so let's graph this guy, y equals 2x squared over x squared minus 9. And with our looking for our asymptotes, let's go ahead and compare the degree on the top with the degree on the bottom, and hey, they're the same. And since they're the same, what we want to do is pick a value that gives us our horizontal asymptote from that. So if the degree on the top and the degree on the bottom are the same, and these are, then we look at the ratio of that leading coefficient on the top, which is a 2, over the ratio of the leading coefficient on the bottom, which is a 1. So I have a horizontal asymptote at y equals 2. So I'm going to have this guy right there. The other thing that's really important is to take that top guy and find where it crosses the x-axis. So if I set 2x squared equals 0, then I'm going to see that x squared equals 0. So x equals 0. All right, and so that's my x-intercept when x is equal to 0. It's going to cross the x-axis. Okay. Now, other than that, I don't know much. So I've picked out some points here to look. The other thing that we need to investigate is where the denominator is equal to 0. So let me erase this math right here. And where that denominator is equal to 0, that's also where we are going to have some vertical asymptotes. So if I take x squared minus 9 equals 0, that gives me x squared equals 9. So x equals the square root of 9 plus or minus. So x equals plus or minus 3. And since x equals plus or minus 3, then at plus or minus 3, I have vertical asymptotes. So now I'm ready to rock and roll. I've got asymptotes lining out my shape, and I'm ready to graph this guy. So I've just picked some points here, put them in a table, and all you need to do is put these points into your calculator and punch it in and see what you get. So basically, it's just going to be, let me change colors here. So it's going to be 2 times -5 squared over -5 squared minus 9. And please remember, when you are squaring -5, that's -5 times -5, which is a positive 25. Okay? Well, when I do the math on this guy and punch it into my calculator, I get 3.1. And then I'm going to do the same thing with -4. So 2 times -4 squared divided by -4 squared minus 9. Punch that into your calculator. And again, -4 times -4 is going to be positive 16. But this guy's going to give me 4.6. And then do it, and that takes care of the 2 points on the left-hand side of my graph. So this takes care of this area right here. Let's go ahead and plot these 2 points then. So I'm at -5, and then I'm at the point 3.1. 1, 2, 3, 1. And then I'm at -4, 4.6. 1, 2, 3, 4. 4.6. So I'm going to have a curve kind of like this. Okay? And that takes care of that left-hand side. So the right-hand side then is going to look like this. So now I'm going to go in the middle. Sorry, not the right hand, in the middle. And I'm just going to do 2 times -2 squared over -2 squared minus 9. And when you punch that into your calculator, you get -1.6. Okay? And I'm running out of room, so I'm going to erase this guy. And then punch 2 into your calculator. And when you punch 2 into your calculator, you're going to have 2. Whoa. Punch 2 in, you're going to have 2 times -2, 2 times positive 2 squared over 2 squared minus 9. And so when you punch that in, you're going to end up with -1.6. And that takes care of your middle piece. So let's graph that guy at -2. -2, I'm at -1.6. And then positive 2, -1.6. So I've got this shape in the middle. And he looks like this. Okay? And then finally on that right-hand side, on the right-hand side of the last asymptote, we've got 4 and 5. So when I do 4 and 5, I'm going to end up with 2 times 4 squared over 4 squared minus 9. Well, hey, guess what? That's going to end up being 4.6. And then the very, very last guy is my 5. And so when I plug that in, 5 squared, 2 times 5 squared, over 5 squared minus 9, that's going to be 3.1. And so if we were to plot those 2 points, out here, 1, 2, 3, 4, 5 and 3.1 and 4 and 4.6. So it's going to look something like this. And so there's your graph for this rational function. It takes a couple minutes to set up. You can check it on your calculator, but that's really all there is to it. You just run it through a series of table of points and checking some different things. All right, here's the last problem that we're going to work out, and it's the most complicated one. And checking this guy out, the first thing that we want to do is look at the degree on the top and the degree on the bottom. And the degree on the top is larger than the degree on the bottom. And so what that means is you look at the ratio of the leading coefficients. And so on this particular problem, that's going to be 1 over 1. So y is going to be equal to 1 over 1 times x to the 2 minus 1 power. And this is one of the things that we talked about on the very first slide. So my asymptote is actually going to be y equals x. Okay, 2 minus 1 is 1. So the line y equals x is my asymptote. And let me make my asymptotes a little bit thicker. So basically what we've got is this guy right here. Okay, we've got this as an asymptote. And the other thing that we need to check is where my denominator equals 0. So we need to know where that is because that's my vertical asymptote. So when I do that math, I get 2. And let's graph that guy. So at the x-coordinate of 2, I have a vertical asymptote. All right. And then I want to come through and I want to find where my graph crosses the x-axis because that's going to be a pretty important deal. And so I'm just going to say x squared plus 3x minus 4 equals 0. And when I factor that out, I get x minus 4 and x plus 1. So x equals 4 and negative 1. That's where I'm going to cross the x-axis. So when x is equal to 4, I get a y-coordinate of 0. And when x is equal to negative 1, I get a y-coordinate of 0. Oh, that's backwards, isn't it? This should be a plus right here. This should be a minus right here. So that's going to give us actually 4, negative 4, and 1. So when x is negative 4, I get a 0. And when x is 1, I get a 0. So at negative 4, 0, 1, 2, 3, 4, 0. And at 1, 0. All right. And then I'm going to just fill in the points, the other points on this graph. So I'll work way over here on the right-hand side of my page. And all I'm going to do is I'm just going to work this math out. So this is going to be, negative 8 squared plus 3 times 8 minus 4 over negative 8 minus 2. And so when I do that math, I get negative 3.6. And then substitute in the negative 4. So negative 4 squared plus 3 times negative 4 minus 4 over negative 4 minus 2. And guess what you should have on that one? Should be 0. And then go ahead and put 0 in. And we love zeros because that just makes life nice. So I'm going to have 0 squared plus 3 times 0 minus 4 over 0 minus 2. And this is a 0. And that's going to be 2. We've done 1, but if you wanted to check 1, it would be 1 squared plus 3 times 1 minus 4 over 1 minus 2, which should give you 0. And then 3 squared plus 3 times 3 minus 4 over 3 minus 2. And if you punch that into your calculator, you're going to get 14. Gosh, my 3 squared won't erase. Do it with 4 squared now. So 4 squared plus 3 times 4 minus 4 over 4 minus 2. When you plug that in, you should get 12. And then 8 squared plus 3 times 8 minus 4 all over 8 minus 2. You plug that in, you're back up to 14. And then, just for giggles, toss in the 12 so you can really see what it's doing. And it starts to increase quite rapidly. And so that's going to end up being 12 squared plus 3 times 12 minus 4 over 12 minus 2, which is 17.6. So, you can find these points. You can look at a table of points. It's pretty bearable to do. And so once you've got your stuff, you can start to apply your points. And so, if we're looking at these guys, let me make my ink a little heavier here. If we're looking at these guys, -8, -3.6, so here's 4, 5, 6, 7, 8, 3.6. It's going to be about right here. And then -4, 0. And then 0, 2. So 0, 2 right here. And then 1, 0, which is right there. And then what we've got is a shape that's curvy, and it looks kind of like this. Okay. And so the closer we go towards infinity, the more it's going to match this asymptote of y equals x. Okay. On the other side of that vertical asymptote, we've got 314, which is way up here. So 314. And then we've got 412. So 412. And then we've got 814. And so what this guy does is he actually ends up making this shape up on the top. And so if you graph this on your calculator, when you graph this, you'll have to change your window probably just a little bit to see the whole graph, but it's all in there. And again, as this graph on the top goes towards infinity, this guy right here is going to be a boundary for that, so it follows the line y equals x.